Here we will see advanced indexing in NumPy. Advanced indexing is triggered when object satisfies one of the conditions. That is, it is an ND array of type integer or Boolean, or it is a tuple with at least one sequence object, or it is a non-tuple sequence object. Advanced indexing returns a copy of data rather than view of it. Advanced indexing is of two types, integer and Boolean. Integer indexing helps in selecting any arbitrary item in an array based on its n-dimensional index. Each integer array represents the number of indexes into that dimension. When the index consists of as many integer arrays as the dimensions of the target ND array, it becomes straightforward. Each element of the first dimension is paired with the element of second dimension. For example, here we have created an ND array with elements 1, 2, 3, 4 and 5, 6, and when we use integer indexing with elements 0, 1, 2 and 0, 1, 0, it will give the output 1, 4, 5. That is, the selection includes elements at 0, 0, then 1, 1 and 2, 0. So it will give the output 1, 4, 5. That is, 0, 0 element is 1, 1, 1 element is 4 and 2, 0 element is 5. Here we will see another example. Here we have created an array with elements 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, 10, 11. And when we give row selection as 0, 0 and 3, 3 and column selection as 0, 2 and 0, 2, and when we print index array with X with rows and columns, it will give the output 0, 2 and 9, 11. Since it will combine 0, 0, that is 0th row and 0th column, which value is 0, 0th row and second column is 2, then third row and 0th column is 9 and third row and second column is 11. So it will give the output 0, 2 and 9, 11. Next we will see Boolean array indexing. This type of advanced indexing is used when the resultant object is meant to be result of the Boolean operations such as comparison operators. This indexing has some Boolean expression as the index. Those elements are returned which satisfies the Boolean expression. Basically, it is used for filtering the desired element values. For example, here an array is declared with elements 10, 40, 80, 50 and 100, and when we print A with A greater than 50, it will give the output 80 and 100. That is, it will print those elements who satisfies the condition, that is, element value is greater than 50. So it will print 80 and 100. Then we will see another example. Here we have declared array with these elements and we will give the Boolean indexing as array 1 less than 10 or array 1 greater than 40. It will give the output 1, 2, 4, 9 and 47, 51, 52. That is, it will print elements those are less than 10 and those are greater than 40 from this array 1. Now we will execute this in Jupyter Notebook. First we will see integer indexing. First we will import NumPy and then we will declare an array. So X equal to np.array with elements 1, 2, 3, 4 and 5, 6. Then first we will print array, that is X. Then we will use integer indexing. So Y equal to X. So 0, 1, 2 and 0, 1, 0, and we will print Y and we will execute this. First it will print array as 1, 2, 3, 4 and 5, 6, and then it will print elements as 1, 4, 5. That is, 0th row and 0th column element is 1, first row and first column element is 4, second row and 0th column element is 5. Then we will see another example. So X equal to np.array 0, 1, 2, then 3, 4, 5, then 6, 7, 8 and 9, 10, 11. Then first we will print original array as print X. Then we will define rows that we are going to select from this array. So rows equal to np.array with 0, 0 and 3, 3, and we will define columns as np.array with 0, 2 and 0, 2, and we will assign Y equal to X of rows, columns, and we will print elements after integer indexing. We will print Y and we execute this. First it will print original array as 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, 10, 11. And when we use integer indexing with rows and columns, so first it will print 0th rows and 0th column. So it will give the value 0. Then it will print for 0th row and second column, it will print 2. Then third rows and 0th column, it will print 9, and third row and second column, it will print 11. Then we'll see Boolean indexing. We will declare an integer array. So x equal to np dot array with elements 10, 40, 80, 60, 100. First we'll print original array. So x. Then we'll print all the elements whose value is greater than 50. So with x greater than 50. And when we execute this, first it will print original array as 10, 40, 80, 60 and 100. And when we print array with Boolean indexing as x greater than 50, it will give the output as 80, 60 and 100. That is, it will print those elements whose value is greater than 50. Then we'll print another array. So x equal to np dot array with elements. First we'll print original array x. Then we'll use Boolean indexing for printing the elements whose value is less than 10 and greater than 40. So we'll give a equal to x less than 10 or x greater than 40. And then we'll print x of a. And when we execute this, first it will print original array as 1, 2, 4, 7, 10, 16, 18, 35, 40, 60, 75 and 90. And when we use Boolean indexing where we will print values less than 10 and greater than 40, it will print 1, 2, 4, 7 and 60, 75 and 90.